Good day everyone, and welcome to today's presentation on branches of digital forensics. So we recorded a lecture, previous lecture on digital forensics, where we discussed the locale exchange theory, the definition of digital forensics, as well as the digital forensics process. Now we are on the branches of digital forensics, and digital forensics is a specialized field that involves the identification, the preservation, analysis, and the presentation of evidence found in digital services. So as technology becomes more embedded in our daily lives, digital devices and digital evidence is increasingly crucial in criminal investigations, corporate disputes, and cybersecurity incidents. So digital forensics is not a single discipline, but a collection of branches, each focusing on different types of digital evidence and sources. So understanding these branches helps investigators choose the right tools and method for each unique case. So we have disk forensics that deals with extracting data, information from storage media by searching active, deleted files, and also from unallocated slack spaces. So this one is concerned with extracting data from storage devices such as hard drives, solid state drives, USB flash drives, and memory cards. So the process involves searching for active files, right, those currently accessible, deleted files which may still be recovered, and the data hidden in unallocated or slack spaces. For example, if a suspect deletes incriminating documents from their laptop, disk forensics experts can often recover these files even if they are no longer visible to the operating system. They also analyze metadata, such as when a file was created or last accessed, to build a timeline of events. Then we have network forensics. This one is a sub-branch of digital forensics relating to the monitoring and analysis of computer network traffic for the purpose of informing purpose of information gathering, legal evidence, or intrusion detection. So this branch is essential for investigating cyber attacks, unauthorized access, and data breaches. Unlike disk forensics, which deals with the data at rest, network forensics deals with the data in motion, that is packets traveling across networks. For example, if a company experiences a data breach, network forensics specialists can examine logs and captured network traffic to determine how attackers infiltrated the system, what data was accessed, and where it was sent. Right. Then we move on to wireless forensics. This is a sub-discipline of network forensics. So the main goal of wireless forensics is to provide the methodology and tools required to collect and analyze wireless network traffic data. Right. So under this one, it deals specifically with wireless network traffic, but it's a sub-branch of network forensics. So its main goal is to collect and analyze data transmitted over Wi-Fi and other wireless protocols. So this is increasingly important as more devices connect wirelessly, right? So this one, investigators might analyze Wi-Fi logs to determine if an unauthorized device is connected to a corporate network and what data is accessed, right? So we move on to database forensics. This is a branch of digital forensic science relating to the forensic study of databases and their related metadata, right? To uncover evidence of tampering, unauthorized access, or data theft. So this branch is vital in cases where critical information is stored in structured databases. So if financial records in a company's database are altered, forensic experts can analyze transaction logs and metadata to identify when and how the changes occurred and potentially who made them, right? This is database forensics. Then we move on to malware forensics, and this one deals with investigating and analyzing malicious code for identification of malware like viruses, trojans, worms, keyloggers, and to study their payload, right? So this is the investigation and analysis of malicious software such as viruses. So the goal is to identify the type of malware, understand how it operates, and determine its impact on the system. So analysts also study the malware's payload, what it was designed to do, such as steal data or disrupt operations. For example, after a ransomware attack, malware forensics experts reverse engineer the malicious code to find out how it encrypted files and whether there is a way to recover the data without paying the ransom, right? So we move on to mobile device forensics. This one focuses on examining smartphones, tablets, and other portable devices. So investigators extracted data such as contacts, call logs. Under call logs, we are tracking of missed, dialed, and received calls. Then there's SMS, MMS messages, paid device history, photos, videos, and audio recordings. So in a criminal investigation, for example, mobile forensics can review a suspect's local history, communication, and even deleted messages, providing critical evidence for the case. Moving on, there is GPS forensics. This one, also known as sat-nav forensics. So this branch involves analyzing GPS devices to retrieve track logs, waypoints, routes, and stored locations such as home or office. So this one is increasingly used in investigations to establish a person's movements and whereabouts at specific times. For example, if a suspect claims to have been at home during a crime, GPS forensics can analyze their car's navigation device or smartphone to verify the actual location history. Then we move on to email forensics. This one is the recovery and analysis of emails, including deleted messages, attachments, calendars, and contacts. So this branch is crucial in fraud, harassment, and some corporate cases. So for example, in cases where in a corporate fraud case, email forensics might uncover deleted correspondence between conspirators, as well as metadata showing when and where the emails were sent or received. Then we move on to memory forensics. This one involves collecting and analyzing data from a computer's volatile memory, the RAM, right? So system registers and cache. So this is essential for uncovering evidence that only exists while the system is running, such as encryption keys, running processes, or active network connection. So for example, during a live response to a cyber attack, memory forensics can capture malware running in memory, even if it leaves no trace on the hard drive. This can reveal the attacker's tool and methods. So each branch of digital forensics plays a unique and vital role in modern investigations, whether it's recovering deleted files, analyzing network intrusions, dissecting malware, or tracking a suspect's movements. Digital forensics provides the scientific tools and methodology, right, needed to uncover the truth in the digital age. This marks the end of our presentation.